Hello everyone, welcome back to the Atharva GATE Academy. Myself Chinmay Daduk. In this video, we will continue to solve GATE questions of Chapter 3, Bending and Torsion. This question is from year 2008. For the component loaded with a force F as shown in the figure, the axial stress at the corner point P is dash. Here component is shown in this figure. This component is having L shape, right? And here cross section of this component is given. We have solved this type of question in 3D part of chapter 3, right? Now here if we draw the line diagram of this component, then this is the fixed end and this will be the line diagram of this component, right? Let's say this point is point A, this is B point and this is C point. So here we can assume that this component is the combination of two components, component AB and component BC, right? Here this F force is acting at this end C. Value of this load is F. Now we know that if we want to find out value of stress at this end, means if we want to find out value of stress in AB member, then first of all we have to transfer this F load on AB member, right? And we know that how to transfer this F load on this AB member. For that, we will take two forces equal in magnitude and opposite in direction at point B. One will be in this direction and second is in this direction. Now we know that this F load and this F load will produce a couple in this member, right? Because these both the force are parallel and opposite in direction. Value of that couple will be F into distance between these two load, that is given as L minus B. And here we have to take distance from this centroidal axis of this member. So M is equal to F into L minus B. So we can say that there will be one moment in this direction having value M. And also this F load will act on this member, right? So one load F is also acting here and this force is cancelled, means actually this force is transferred on this member here, and after transferring this F load here, there will be one axial load F and one bending moment M. Fine. Now we know that at this point value of stress will be the stress by this axial load F and stress by this bending moment M. So stress at point P is equal to axial stress plus bending stress. Now we know that axial stress is simply load divided by area. So it is F divided by area is area of this cross section, that is 2B into 2B. So it is 4B square plus value of bending stress is My by I. This is the equation to find out bending stress, right? Now here we know the value of M, that is F into L minus B. This I will be the value of second moment of inertia of this cross section about this axis. And we know the equation that I is equal to 1 upon 12 this side cube, that is 2B cube, into this side, that is 2B. So ultimately it is 16 divided by 12 B raised to 4, correct? And here what will be the value of Y? We know that Y is the distance from this neutral axis, right? Here we want to find out stress at this point, means we have to take distance from this neutral axis up to this end, and this whole distance is given as 2B, that is given here, right? So this distance is B, means in this case Y is equal to B. So it is equal to F divided by 4B square plus M, that is F into bracket L minus B. Y is B divided by I is 16 divided by 12, that is 4 divided by 3 B raised to 4. And now we have to simplify this expression. If you will simplify this, then you will get answer option D, F into bracket 3L minus 2B by 4B cube. Fine. So I hope that you understand this question. Here first of all we have to transfer this F load on this AB member, and then we have to find out total value of stress by adding value of sigma A and sigma B, that is the stress by this axial load F and bending stress, that is stress by this moment M. Now also understand one thing, that this axial stress is stress by this tensile force F, so it is taken as positive, and here this bending stress is stress at this point, and this moment is acting in this direction. So stress at this point will be positive and stress at this point will be negative, right? That we have discussed in the theory part. Here at this point, or we can say in this portion, value of stress by this moment will be positive, means it will be tensile, and in this part value of stress by this moment will be compressive, means it will be negative. If it is asked to find out value of stress at this point, then we have to take this bending stress as negative. So here it will be negative. And see, if it is asked to find out stress at this point, then it will be stress by this axial load only, because bending stress will be 0. Why? Because at this point value of y is 0, right? So I hope that you understand the variation in this example. This question is asked for 2 marks. Next question is from year 2009. A solid shaft of diameter d and length L is fixed at both the ends. A torque of T0, it is T0, is applied at a distance L by 4 from the left end as shown in the figure given below. The maximum shear stress in the shaft is dash. Means here we have to find out tau maximum. We know the equation of tau maximum, that is 16T by pi d cube. And here T is the value of twisting moment in the shaft. In this example, this T0 twisting moment is applied at this point, which is at the distance of L by 4 from this end. And here we can assume that this left side of shaft is shaft 1 and this right side of shaft is shaft 2. Here we directly cannot take this T is equal to T0. Why? Because this twisting moment T0 will distributed among this shaft. So here first of all we will find the value of twisting moment in each shaft, and then we will put value of twisting moment here, and then we will find value of maximum shear stress. Now to find out twisting moment in each shaft, first of all we have to find the reaction at these ends. Let's say at this end value of reaction, that is reactive twisting moment, is T1, and this end we are assuming that twisting moment is T2. Here this twisting moment is in the anti-clockwise direction, so I have taken this both the reactive twisting moment in clockwise direction. Fine. First of all I will tell you the method to find out T1 and T2, and then I will directly tell you the shortcut to find out T1 and T2 directly. Now first of all we can understand that T1 plus T2 is equal to T0. Why? Because this shaft is in the equilibrium, and we know that if shaft is in the equilibrium, then total value of torque applied on this shaft should be 0. So here we can say that value of torque in clockwise direction is equal to value of torque in anti-clockwise direction. So we have this one equation, T1 plus T2 is equal to T0. Now here we know that a value of deflection in shaft 1 and shaft 2 will be same, because value of deflection at this surface will be the value of deflection in shaft 1, and that will be equal as the value of deflection in shaft 2, right? So here we can say that theta 1 is equal to theta 2. Diameter of both the shaft is also same, so value of J is same for both these shaft, right? J is equal to the polar moment of inertia, that is pi by 32 d raised to 4, right? And in this case material is also same for both this shaft, so we can say that G1 is equal to G2. Now we know that theta is equal to TL by Gj, right? That is the equation to find out theta. Now from here we can say that T1 L1 divided by J1G1 is equal to T2L2 divided by J2G2. Now we know that J and G are same for both these shaft. So we can cancel J and G. So from here we have another equation, T1L1 is equal to T2L2. Here this T1 is the twisting moment in shaft 1 and this T2 is the twisting moment in shaft 2. Now we know that how to find T1 and T2 for these two shafts. If we want to find out T1 means value of twisting moment in shaft 1, then we have to take one section in shaft 1 and we have to take summation of all the twisting moments acting on this shaft either side of this section. Here if we take left side of the twisting moment, then there is only one twisting moment, T1. So here T1 is equal to T1, right? Here this T1 is reaction at this end and this T1 is the value of twisting moment in this shaft, right? Similarly here if we find value of T2, then for that we have to take section in shaft 2 like this and we have to take summation of all the twisting moments acting on this shaft either side of this section. And here if we take right side of the twisting moment, then it is T2, right? So in this case twisting moment in shaft 2 is T2, that is value of reaction at this end. Here we have value of L1 and L2. L1 is equal to L by 4 and L2 is equal to 3L by 4. So if you will put this value here, then you will get relationship between T1 and T2. And then you have to solve this equation and this equation. And by comparing these two equations, you will be able to find T1 and T2 in terms of T0. So this is the one method to find out T1 and T2 in this shaft. But now I will tell you shortcut to find out reactions at these ends. See, if we want to find out T1, then we have to multiply this T0 with this opposite length, means with 3L by 4 and divide by total length L. Means if we want to find out reaction at this end, then we have to take distance between this point and opposite end divided by this total distance. And if we want to find out T2, then we have to take this opposite distance, this distance, that is L by 4, into this T0, that is twisting moment applied at this end, divided by this total length, that is capital L. So now you can directly find the value of T1 and T2 in terms of T0. But remember that this shortcut is only applicable if the diameter is constant and material is same. If this material is not same or diameter is not same, then we have to follow same method as discussed earlier. Now here we can find out T1, that is 3 by 4 T0, and here T2 is T0 by 4, right? And we know that this T1 and T2 are the value of twisting moments in shaft 1 and shaft 2. If we want to find out maximum shear stress in this shaft, then we have to take maximum value of twisting moment. Here we can understand that maximum value of twisting moment is T1. Here T1 is greater than T2, right? So to find out maximum shear stress, we have to take this twisting moment is equal to 3 by 4 T0. And if you will put this 3 by 4 T0 here, then you will get 12 T0 by pi d cube, right? So here our answer is option B, 12 T0 by pi d cube. This question is for 2 marks. See here, if you know this shortcut, then this question is very easy and you can easily get 2 marks. Fine. Next question is from year 2011. A torque T is applied at the free end of a stepped rod of circular cross section as shown in the figure. The shear modulus of the material of rod is G. The expression for D to produce the angular twist theta at the free end is dash. Means here we have to find out diameter in terms of T, L, theta and G. Fine. In figure you can see that there are 2 shafts attached in series connection. Diameter of this first part is 2d and diameter of this second part is d. Length of this first part is L and length of this second part is L by 2. We apply this twisting moment at this free end, and here this theta means angular twist is at this end, means here angular deflection is theta. Fine. Now understand that this theta will be the total deformation of the combination of this shaft, or we can say the rod, and we know that total deformation is equal to theta 1 plus theta 2. This total angular deflection is equal to angular deflection in part 1 plus angular deflection in part 2, right? And we know the equation that theta is equal to TL by JG. So here we can write that theta 1 is equal to T1L1 divided by J1G1 plus theta 2 is T2L2 divided by J2G2. Now in this expression we know the length in both the shaft, and we also know the shear modulus G1 and G2, that is G for both this shaft. We can find J means polar moment of inertia of both this rod, that is pi by 32 d raised to 4. To find polar moment of inertia in part 1 we will take diameter is equal to 2d, and to find polar moment of inertia for this second part we will take diameter is equal to d. Now we have L, J and G, but we have to find out twisting moment T in each shaft. Now if we want to find out twisting moment in shaft 1, then we will take one section in shaft 1 like this, and we will take summation of all the twisting moments acting on this shaft either side of this section. Now here on the right side we apply this twisting moment T. So for shaft 1 value of T1 is equal to T, and here we are taking this clockwise direction as positive. Fine. Now if we want to find out T2, then we will take one section in part 2 and we will take summation of all the twisting moments either side of this section, and here we will also take right side of the twisting moment. So T2 is also equal to T. So now we will put these values in this expression. So it is T into L1 is L divided by pi by 32 into bracket 2d raised to 4 into G plus T2 is T. So it is T into length is L by 2 by pi by 32 d raised to 4 into G. Fine. And here this expression is equal to theta, right? Now here in this expression we can take twisting moment, length, G and diameter common, right? So after taking common, if you will simplify this expression, then you will get diameter in terms of T, L, theta and G. And if you will calculate this, then you will get answer option B, 18TL by pi theta G raised to 1 by 4. Fine. So in this question answer is option B, and this question is for 2 marks. Next question is from year 2014 paper set 3. Two solid circular shafts of radii R1 and R2 are subjected to same torque. The maximum shear stresses developed in the two shafts are tau 1 and tau 2. If R1 by R2 is equal to 2, then tau 2 by tau 1 is equal to dash. Now we already know the equation to find out tau maximum in solid circular shaft under the action of torque, right? That is 16T by pi d cube. Now here it is given that both the shaft experience same torque. So value of T is same for both the shaft 1 and shaft 2. Now from here if we take ratio of tau 2 by tau 1 means maximum shear stress in shaft 2 to the maximum shear stress in shaft 1, then it will be d1 raised to cube divided by d2 raised to cube, right? Because here this T is same for both the shaft, and this 16 and pi is cancelled from numerator and denominator. So finally our answer will be d1 by d2 raised to 3. Now see here, ratio of radius is given and we know that diameter is equal to 2 times radius. So actually this ratio is nothing but the ratio of radius. And we know that R1 by R2 is equal to 2, so it is 2 cube, means it is equal to 8. And here no options are given, here we have to write answer 8. So I hope that you understand this question. This simple question is for 1 mark. Next question is from year 2015 paper set 1. Consider a stepped shaft subjected to a twisting moment applied at B as shown in the figure. Assume shear modulus G is equal to 77 gigapascal. The angle of twist at C in degrees is blank. Here we have to find out value of theta at this end. Now here we can consider that there are two shafts, shaft AB and shaft BC, and these shafts are fixed at end A and it is free at end C. And here this twisting moment T is equal to 100 Newton into meter is applied at end B, or we can say at point B. The dimensions are given in this figure. This symbol shows the diameter and here this is the length of both these shafts. We have to find out deformation at point C, or we can say at end C. Fine. Now understand that deformation at C, or we can say the angle of twist at end C will be the total angle of twist of this combination, right? So actually we have to find out theta AC. Now see here you can directly solve this question because here twisting moment at B point and C point will be same. Why? Because there is no any twisting moment applied in this BC part, right? We can say that this theta AC is angle of twist of this C with respect to A. And we know that theta AC is equal to theta AB plus theta BC. And we also know the equation of theta, that is TL by JG. Now we are going to put these values here. So it is TL by JG for AB plus TL by JG for BC. Now in this expression length is given to us, right? And diameter is given to us. So we can find out J, that is pi by 32 d raised to 4, and value of G is also given to us. We only need to find out value of twisting moment in each shaft. Means here we have to find out T in AB and T in BC. And we know that how to find value of twisting moment in each shaft. If we want to find out twisting moment in shaft AB, then we take section in shaft AB and we take summation of all the twisting moments applied on this combination of shaft either side of this section. Here we will take summation of right side of the twisting moment applied on this shaft. And on the right side you can see that there is only one twisting moment, this T applied on this shaft. So here TAB is equal to T. And if you want to find out twisting moment in this BC shaft, then we have to take section in BC shaft like this, and we have to take summation of all the twisting moments applied on this shaft either side of this section. Now here you can see that on the right side of this section there is no any twisting moment. So here T in BC part is 0. Means twisting moment in part BC is 0. Now understand that why we have not taken value of twisting moment 0 in this section. Because you may think that on the left side of this section there is no any twisting moment acting on this shaft, right? But actually there is one fixed end on the left side of this section, and we know that at fixed end we get reactive twisting moment like this. So actually on the left side there will be one reactive twisting moment applied on this shaft. So in the part AB value of twisting moment is not 0. But in part BC on the right side there is no any twisting moment, right? So here we have taken this value as 0. And if this T in BC part is 0, then this term will be 0, right? So this total term is 0. So finally we have to get the answer of this term. And we know all the values T, L, J and G. This T is 100 Newton into meter. This length is 500 mm. This J is pi by 32 d raised to 4. And this G is 77 gigapascal. Now to find out value of angle of twist, you have to take care in the units. Here if you will take this torque in Newton into mm, this length in mm, value of J in mm raised to 4, means you have to take diameter in mm, and if you will take this value of G in megapascal, then finally you will get theta in radian. So here whatever be the value of theta, that will be in unit radian, and here it is asked the answer in degree. So finally you have to convert this radian value into degree value, and for that you have to multiply this value with 180 by pi. Then you will get answer of this question. Fine. If you will calculate this, then you will get answer 4.133 into 10 raised to minus 3 radian. This answer is in radian, and if you will convert this value in degree, then you will get answer 0.236 degree. So here you have to write answer 0.236. Fine, and this question is for 1 mark. And here understand one thing, that deformation at end B and end C is same, because there is no any other twisting moment applied between B and C. So the deflection at C will be equal to deflection at end B. Fine. So I hope that you understand these questions and concept that we apply in these questions. Today we will stop here and we will continue in next video. Till then, stay motivated and happy practicing.